He knows a lot about the science stuff. Professor Dave explains.
Okay, let's practice balancing redox reactions. Consider the following oxidation-reduction reaction. We have MnO4- plus Fe2 plus yields Mn2 plus Fe3 plus. Now we want to balance this reaction under acidic conditions. So if you're not sure how to approach this, go ahead and check out my tutorial on this subject, and when you're ready, give it a try. So let's put our reaction up top. Now what are we going to do first? The first thing we have to do always is we're going to split this up into half reactions. So the oxidation half reaction is Fe2 plus to Fe3 plus. That is the oxidation half reaction because iron is oxidized. We go from iron 2 to iron 3. So iron has lost an electron. And the reduction half reaction is MnO4- to Mn2 plus. That is a reduction because we're going from manganese 7 to manganese 2. If you find the oxidation number for manganese in MnO4-, that is going to be 7. And so we're going from 7 to 2, that is a reduction. Now step 2, we're going to have to balance oxygen with water molecules. So the oxidation half reaction doesn't have any oxygen, so we don't have to worry about that. But the reduction half reaction does. So we have 4 oxygen atoms on the left because we have MnO4. So if we have 4 oxygen atoms, we're going to need 4 water molecules on the product side because each water has 1 oxygen. So let's put 4 waters there. Now step 3 is to balance hydrogen with protons. So once again, the oxidation half reaction, we don't have any hydrogen, we don't have to worry about it. But we have just put 4 waters for the reduction half reaction, so we're going to have to balance those hydrogens. So if we have 8 hydrogens on the right, because there are 2 per water molecule and there are 4 waters, we need 8 H plus ions on the left. So that's the end of step 3. Let's bring this up to the top so we have some more room to finish up. Now step 4, we're going to have to balance charge with electrons. So on the left, we have a +7 charge total because we have a -1 charge, and then we have 8 +1 charges because we have 8 protons. So -1 plus 8 is +7. And on the right, we just have a +2 charge from that one Mn2 plus ion. So we have +7 on the left, and we have +2 on the right. That means we're going to need 5 electrons on the left to balance the charge, because if we have a +7 charge, we need 5 negatively charged particles to bring that charge from 7 down to 2, so that we have a +2 charge on both sides. Now at this step, we're finally going to have to bring back the oxidation half reaction because that charge is unbalanced. And so we're going to need 1 electron on the right to bring the 3+ charge down to 2+, so that we have 2+ on both sides. Now the next step is to match the number of electrons and then combine the half reactions. So we need the number of electrons in these 2 half reactions to be the same so that we can combine them. And on the top we have 5 electrons as reactant, and on the other one we have 1 electron as a product. So what we need to do is multiply this entire oxidation half reaction by 5, which means we have 5 Fe2 plus yields 5 Fe3 plus 5 electrons. And now we are ready to combine these, which means we're just going to add everything up, and we altered the number of electrons so that we could cancel them. We have 5 electrons on the left and 5 electrons on the right. Those will cancel, and now we just add up everything else. So let's take all of the reactants. We have 5 Fe2 plus MnO4- plus 8 protons. And then on the product side, we have 5 Fe3 plus Mn2 plus 4 waters. And this equation is now balanced under acidic conditions.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.